Hi friends, going through AP problem week 8, 15 and 16. For the first one, we're going to do a little implicit, so I'm going to end up getting y squared plus 2xy dy dx. And then I'm going to have minus, and whenever I have a minus, I keep that minus separate. I'll take the derivative using product rule. It probably is going to be backwards from you just because I learned it differently than you did, is equal to 0. So I'll distribute xy dy dx minus 3x squared y minus x cubed dy dx. Everything that doesn't have a dy dx moves to the other side. So I'll factor out a dy dx. 2xy minus x cubed is equal to 3x squared y minus y squared. And my final answer is exactly. Now, those of you who didn't get full credit, you had some kind of bad math going on with your negatives. So 3x squared y minus y squared over 2xy minus x cubed. Okay, find all points on the curve whose x coordinate is 1 and write the equation. So if x equals 1, then you're left with the original equation, which would have given you y squared minus y equals 6. And you got a couple points for that. And then when you solved, y squared minus y minus 6 equals 0. Y minus 3 times y plus 2. So y is equal to 3 or negative 2. Okay, now they're asking you to find all points on the curve and write the equation of the tangent line. So a lot of you got the slope. Okay, so we've got 1 comma 3 and we've got 1 comma negative 2. So I need to go find the slope. So if I do dy dx evaluated at the point 1 comma 3, I believe I end up getting that slope is 0. Well, if the slope is 0, that's a horizontal line, so it's just the equation y equals 3. Okay, those of you who wrote out like y minus 1, y minus 3 times 0 times the quantity x minus 1. Why? Can we just recognize that the slope is 0 is a horizontal line? Horizontal lines are written y equals. That'd be great. Okay, dy dx evaluated at the point 1, negative 2. I believe I get 2. And so now I will go right and point slope y plus 2 is equal to 2 times x minus 1. Why are we going to solve for that? Don't. We're done. Okay, so my two tangent lines, I'm circling for emphasis. Okay, those are the equations. All right, then it says find the x coordinate of each point on the curve where the tangent line is vertical. So kudos to those of you who looked at that slope and you're like, well, I better set that slope, the denominator, equal to 0. So 2xy, if it's a vertical tangent line, I better have an undefined slope. So I've got x cubed, 2xy minus x cubed, that's right. Okay, so I want to know where this is equal to 0. Okay, friends, we cannot divide by x, okay? That pretty much tells me that you're still stuck in like the junior high math course. Okay, cannot divide by x, because if x is 0, you just committed, complete illegal action by dividing by 0. So what I'll do is I will go and factor out factor out an x here, and I'm left with 2y is minus x squared is equal to 0. So now what I'm going to do is I'm going to say, okay, well then that means that x equals 0, or 2y minus x squared equals 0. Well, if they want you to find the x coordinate, that doesn't mean that they want you to just go and get y equals x squared over 2. Okay, that's not what they want. You should actually go and check your answers. So when I go and check when x equals 0 in the original, I end up getting 0 equals 6. This, my friends, is not an option, okay? So this is not, you should have said, yeah, no, x equals 0, not working for me. The next thing you need to do is go plug this into the original equation. So we get x times y squared minus x cubed y is equal to 6. So now I'm going to get x, and y in this case is now x squared over 2 minus x cubed, oh, this is squared, times x squared over 2 is equal to 6. Solve. So that's what a lot of you missed on that, okay? All right, then last but not least, problem 16. I thought 16, you guys did a great job on this. Okay, if I look at this, so they're telling me I've got all these requirements to meet. Okay, so f of x equals ax squared, where a is a non-zero constant. Show that it is not possible to find a value of a so that f meets requirement 2. Requirement 2 says that the value of the function is 1. Okay, so at x equals 4. So f of 4 equals 1. And f prime of 4 is also equal to 1. So if I go and solve for a here, I'm going to have f of x is equal to ax squared, and I plug in what do I know? That 1 is equal to a times 4 squared. So I know that a here is 1/16. But if I do this, f prime of x is equal to 2ax, and I'll have 1 is equal to 2a times 4. I'm going to get that a equals 1/8. No bueno. Now, some of you did a little bit different, and it was totally fine, okay? For part B is asking you to find where C is a non-zero constant. Find the value of C so it meets requirement 2. Okay, so what do I know? I know that g of x is equal to c x cubed minus x squared over 16. And requirement 2 again says f of 4 equals 1. And f prime of 4 is also equal to 1. Okay, so I better go and find, okay, 1 is equal to c times 4 cubed minus 4 squared, right, over 16. And if I do that math, okay, I believe I will get c equals 1/32. And I'm going to double check that with g prime of x is going to be 3cx squared minus 1/8 x. And I'll plug in 1 is equal to 3c times 4 squared minus 1/8 times 4. And if I solve for c again, I'm going to get c is equal to 1/32 again. So yay, we got the same value. And that was a lot of work for just 1 point. Okay, for part C, it says using the function g and your value of c from part B, show that g does not meet requirement 3 above. Okay, requirement 3 being that the function is increasing. So if I know using g and c, I'm going to put that together. G of x is now equal to 1/32 x cubed minus x squared over 16. And I am going to go, how do I figure out that if a function is increasing or decreasing? I'm going to take the derivative and get my critical points. So if I do that, I end up with 3/32 x squared minus 1/8 x. And if I get, I can get my critical points, which I know some of you did, okay? Or I could just go and say, well, g prime of 1, if I plug in 1, 3/32 minus 1/8 is less than 0, so I know that it is decreasing. G of x is decreasing at x equals 1, and so therefore does not meet requirement 3. Okay. Okay, last one here, we have h of x is equal to x of x to the nth over k, where k is a non-zero constant. Find the values of k and n so that h meets requirement 2 above. Okay, and then show that it also meets, okay, again, requirement 2 says that I know that h of 4 is equal to 1. Okay, isn't that what requirement 2 says? Yep, that the function is equal to 1, and I know that h prime of 4 is also equal to 1. So if I do h of 4, I'm going to get 4 to the n over k is equal to 1. Okay, what does that tell me? Well, k equals 4 to the n. That's what I did. Okay, then I also know that h prime of x is going to be n times x to the n minus 1 all over k. Okay, I'm just implying or putting into place rules for derivative. Take n, multiply it by x, take your exponent down by 1. So if I do h prime of 4, I'm going to get n times 4 to the n minus 1 over k is also equal to 1. So now from here, I'll get that k is also equal to n times 4 to the n minus 1. So if these guys both equal k, they better be equal to one another. So 4 to the n equals n times 4 to the n minus 1. And if that's the case, right, if I go and divide by 4 to the n minus 1 over 4 to the n, remember they have the same base. So same base, subtract your exponents, right? N minus the quantity n minus 1, you're going to get 4 is equal to n. So right there, you know n is equal to 4, which means k is equal to 4 to the 4th power, which is 256. Okay, now to prove meet requirement 1 and 2, well, requirement 1 says that at x equals 0, so I now know that h of x is equal to x to the 4th over 256. So h of 0 is 0. So h of 0 equals 0. That's a check. Okay, and now I have to check that it is increasing. So if I do h prime of x is equal to 4 over 256 times x to the 3rd power, okay, I have to talk about what are the values that will always be positive on 0 to 4. So you're done, okay? Let me know if you have any questions.